All right, let's have a look at question 16b. Now, the key bit of information in 16b is that it's degree 7. So I know that I'm going to have like x take alpha, x take beta, x take, I don't know, epsilon, all the way until I've got 7 of them. But what you can see straight away is that that looks like a squared. Because this thing looks like a parabola. I need to make these thinner. Yeah, that definitely looks like a parabola, doesn't it? And this also looks like a parabola. So we can also assume that that's a square. Now, I'm going to show you what this thing looks like. I'd kind of like you to have a guess. We've looked at it fairly recently. But if I were to write this out, then I've got my zeros. So this one's -1, so that becomes x plus 1. And I know it's a squared. And I know this one's x at positive 3, so that's x take 3, and that's a squared. I know I've got a 0 here, and that's x take 1. We know it's degree 7, and we know at the moment we've got 2 plus 2. So what must be here? 3. And that's what I was hinting at. This thing in the orange here, it looks like a cubic graph on its own. So that's a cubed root right there. Now, I don't know if that's the actual thing because I could have had something out the front that wouldn't have changed the cube. So I'm going to chuck an a out the front. And then I'm going to sub in this point, the y-intercept, which is the point 0, 9. So that's x equals 0, y equals 9. I'm going to see what a is. So I've got 9 equals a times 0 plus 1 squared, 0 take 3 squared, 0 take 1 cubed. So 9 equals a. Now 0 plus 1 is 1 squared is 1. Negative 3 squared is positive 9. Negative 1 cubed is negative 1. So 9 equals a times negative 9. So a is negative 1. So y equals negative x plus 2 squared x take 3 squared x take 1 cubed. And I actually quite like being able to answer something like that. That's a very complicated question. Well done to those people who got close.